Hello, dear friends. So, welcome once again to my continuation to my series. Actually, in the last lecture, we discussed about the CDR structure and other things. So now we are moving towards the charging model. So basically, I'll give you first the basic information about the what is charging. So most of you who are from the telecom background and other background where they have heard about the charging term, they must be knowing that charging is nothing. There are two types of charging, basically the offline and the online charging. So here we are talking about the online charging. In online charging also there are three models, okay, where there is a slight difference in all three of them, that how user is getting charged. So it's a very simple example I can tell you. Like, let's say in the app store you have some app which you want to purchase. Okay, it is costing you, let's say, 5 rupees for a monthly subscription. So that is actually a service which you want to buy, and you will be charged for that. So generally you click on buy now, and it will deduct you from your credit card, debit card, or Paytm, or sometimes it will directly charge from your operator. Okay, so basically it will come in your bill, or maybe it will be deducted from your prepaid balance. So all this happens on the real time. Why real time charging is required? So that the service provider who is giving you the service, means that particular Android app provider which is giving you that service, it can it will get the proper amount immediately, and then he will, means that particular provider will deliver the service. Okay, so I hope you got the idea about the charging. Now let's start with the three types of charging models. So the first model here is the IEC, which is immediate event charging. So as the name suggests, immediate event charging means the user will click on buy now, okay, from any service provider, and immediately this request will go to the source from where the charge has to be deducted, either a wallet or a telecom bill, or your main account balance. And if the amount is there in the balance, it will be deducted, and the confirmation will come back to the service provider, and service provider will give the confirmation to the user, and then service provider will start delivering you the service. Okay, in this model, the limitation is that there is only a one shot. So if the balance is there or not there, these out of these two, any one situation will be there, and there will be success and failure based on that. Okay, it is good also because there are very limited number of steps, but it has some drawbacks also that you will come to know when you will move towards the next charging. Okay, so let me see. Yeah, this is immediate event charging. So if you can see the diagram clearly, you will see that this is a user, and user is initiating a charging request towards the basically you can imagine here that user is not directly sending the request. There is a mobile app or website or browser or any other, some kiosk or some other system where user is using, and based on that, user is giving the means giving the confirmation to buy that particular service. Now that service provider is sending the request towards the service element, okay, which is charging trigger function, okay, CTF here. Now charging trigger function will trigger this towards the OCS, means the online charging system. So here the online charging system could be any, it could be a telecom online charging system also, or any other charging system also. But since this is means I'm from telecom background, so better I will give an example of online charging system in telecom, wherein the services charges will be deducted from the OCS. Let's say you are being subscribed for a caller tune, okay, for monthly subscription. So for that you have uh, raise this request, and this will come to a charging trigger function, and it will directly go to your OCS. Now OCS, the parameter which will go to the OCS will be your MSISDN, your event type, okay, the charges which has to be deducted, and it will come in form of CCR, the credit control request, and it will come to OCS. OCS will check the balance of the subscriber, authenticate the subscriber, and if balance is there and the subscriber is valid, then OCS will give the acknowledgement back to service element with the charge, and OCS will debit the charge from here, and in turn service element will come to know that charge has been deducted, and it will confirm back to the user or the service provider. Now service provider will start delivering the service to the user. Okay, so this is immediate event charging. Okay, now When I will explain you ECUR, then you will come to know what is the difference between the immediate event charging and this kind of charging. So the name of this charging type is event charging with unit reservation. Now user here is requesting a service event towards the CTF, and CTF is then uh, raising the credit control request towards OCS. Now it's so see, this is a two-step procedure. In the first step, this will be a request for authorization for the service event and the reserve and to reserve the credit. So in the previous example, if you see in the single event itself, the authorization was also happening, okay, and direct debit was happening, okay. Now in here, in the first step, a service element is just trying to authorize the subscriber, okay, and reserving the credit. So if the credit is there, it will be reserved and it will be gone to the service element. Now yeah, now for the second time the termination request will come, okay, which will tell that the OCS that the report means the deduction was successful or it is a failure, okay, and then the credit will be debited. That means the balance will be debited from the user account, and acknowledgement will go back to the service element, okay, and then the user will be notified. So basically this is the serving element. So first service element is giving the request, reserving some balance, means authorizing subscriber, then reserving some balance, and based on that, service element is giving the service to the user. Once the service means once the balance is deducted, then the final debit is happening on OCS, and then after this confirmation, the service is getting delivered to the end user, okay. Now the third type of charging is okay. Now I hope you are able to differentiate between these two type of charging. Both of them are direct debit charging. The only difference is that there is no reservation in this particular charging, and there is a reservation mechanism, then debit. So this is direct debit. This is reservation come debit. Okay. So now the session charging with unit reservation. So friends, if you have if you have seen my all of the other videos where I have actually opened whole of the TCP dump, and I am explaining you that how rating group is there, how the balance reservation shown in the different AVPs, the MSCC AVPs and other AVPs. So now this charging which I'm going to explain now is the actual data charging which happens with the help of diameter based protocol like GY, GX and SY. So GY, GX and SY actually runs over this kind of charging, the model they implement, which is session charging with unit reservation. Now here if you see, there is a request for an event, okay. Now this is almost similar. Here you will see that, okay, the CCR will be initiated and there will be a requested service unit. So service element will tell that, okay, this much particular unit I'm requesting you. Now OCS can override the service requested service unit with the GSU, means the granted service unit, okay. So once the granted service unit, just a second. Yeah. So once the granted service unit is given to the service element, then service element will start delivering the service. So now you can imagine start delivering the service means the user can start browsing the session. Okay, so the good thing is here is like means that the moment user starts a session for the first time, the session ID is created on the diameter level, okay, the AVP level, and throughout the session, the same session ID will keep continuing unless and until there is some disconnection or the user forcefully disconnect the connection or there is some other changes or network changes happens. Otherwise, same session ID will keep continuing, because why unnecessary we will create again and again the connection, okay, because user is browsing. And nowadays we are in an era where data connection goes all throughout the day, night, 24/7, 365 days. Data is always on, okay, whether you are sleeping but your phone is always on, your data is always working. So that's the reason this SCUR kind of charging, means the session charging with unit reservations, helps a lot, okay. But everything has a good and bad thing. So the bad thing about this is that you need a very high end servers to handle such kind of traffic, because if you have millions of subscribers in your network, and each of subscriber is browsing heavy data, or even the session is open, you can see that request is directly coming here and reservation is happening. I'll explain you more about the call flow, but the main thing here is you can see these dialogues are being opened. For a single subscriber, dialogue is always open. debit reservation will keep on coming with the same session ID. It means there is a dedicated session for every user. So the end system means the infra side, the server should be capable enough to handle such kind of huge traffic. Okay, so most of the legacy system and the vendor owned systems like Ericsson, Nokia, and Huawei, they provide the very high end systems. Moreover, their application stack is also very strong to support such kind of charging. Okay, so let's come to the point. So call flow, this will be a CCR. Okay, then requested service unit, RSU stands for requested service unit, wherein the authorization will happen for the user. Then the reservation will be given to the user via CCA. Okay, service element. Now service element will start delivering the service. Now user started the session. Now now the second will be the used service unit. Okay, and the requested service unit will keep come, means user has started using the service, and while using the service at particular interval of time, the update is happening, interim update. So this is the interim update wherein whatever user has used reports under USU, and whatever user is requesting against, just like the first call flow, it is sending as a requested service unit. Then again, charging system is evaluating the user, and based on the tariff and whatever benefits the user are having, the quota user is having, it is sending the update with granted service unit. So what is used service unit? So whatever was granted here, out of that, whatever subscriber has used, that will be debited from his quota. And a new requested service unit will be issued as a granted service unit to the user. So you can correlate these two flows, that here requested service unit, granted service unit. Here also, if you hide USU, you will see the same RSU and GSU. Okay, USU is extra. Why? Because it is reporting you the use service unit. However, when the initially session was created, only RSU was there, USU was not there. So if you are having any TCP dump where you are seeing USU and RSU together, automatically the thing which should come to your mind is that this is a update request, not the initial request. Okay, so this is initial, this is update, you can see. Okay, I have already shown you the TCP dump. You can refer to my old videos. You will definitely get how SCUR request looks like and how reservations are happening. Now again, these things will keep continuing until and unless there is a quota. There are many different use cases, but one use case explained here is the final unit indication. Means you are having 10 GB. Okay, the requested service unit started with, let's say, 5 MB, and 5 MB was used and 5 MB was again requested. So 5 MB, 5 MB, 5 MB, 5 MB, this on keeps on continuing until your last 5 MB out of your 100 GB. So let's say, so this is the good thing about this application, that the application, means the charging application, has a tariff, and tariff can see and easily detect that, okay, this is the last chunk which I am giving you out of your quota of 10 GB. Okay, and this is the last 5 MB, let's say. So there is a provision where I can send a flag indicating that, boss, this is the last chunk you are using, and after that you have to basically either your session will be slowed down, or it will be throttled, means it will be disconnected, or pay as you go will apply, whatever it is. That is a different scenario. But however, this flag will just help the service element to know that this is the last chunk which is going to be used. Okay, so GSU, again here GSU is again same, but the FUI, which is final unit indication, will tell the service element that is the last chunk. And service, what is help of this flag? Actually, this flag helps this particular CCA request to be differentiated from these two, and based on this particular final unit indicator, the service element can even redirect the subscriber to some portal to buy the latest offers, or it can flash some SMS notification also that your subscription is going to expire or something like that, and then user, it means there are different way to trigger a user for buying the packs or to explore new offers. Okay, so this is how this is, and you can see after that stop delivering service, means this particular use case is where the final unit indication is given, and after that quota is finished and user services will be stopped. So this indication will go to the user that services are stopped. Okay, now once the services are stopped, then session which was created here, my friends, remember here the session which was created with single session ID, that session was with the same session ID was continuing here, 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 and at the end when stops delivering services event happens, then there should be a termination request coming in towards OCC for that user. Otherwise, as I told you, that user session will keep continue, then it will unnecessarily take the resources of the high-end servers. So we should kill that session. So automatically, this is the feature of application. If user doesn't have any pack, and we should stop his data package. So there will be a termination request automatically be generated from CTS after seeing this CTF from after seeing this FUI. That will be the CCR termination request. Okay, and in that the final UCS service unit will be given and termination acknowledgement will be sent to the service element, and this session will be teared down. Okay, this is at the subscriber level. Okay, so subscriber session started here and subscriber session stopped here. And between this, the reservation debit, and finally unit indication, three use case we described. Okay, now there are this is the next topic, and let me just give you a quick summary. So this is the immediate event charging, wherein there was a single shot. We were authorizing the number, we were debiting the user, and we were delivering the service. In ECUR, which is event charging with unit reservation, we are first authorizing the user, then we are reserving the credit, and once the credit is reserved, the service element is triggering the service element is then terminating uh, terminating the session. Okay. In SCUR, then first initial CCR initial comes in, where requested service unit, then granted service unit, then update happens with USU and RSU, USU and GSU, and then final unit indication comes in the picture, and then termination happens. Okay, final unit indication use case will only come when the quota is finished. Okay, however, if let's say the user forcefully stopped his session, then the termination request will come from the network towards the CTF, and CTF will inform OCS for terminating the session. Okay, now this is a very interesting topic, which is QoS, the quality of service. So now, as you can see in this, as I told you, like very high-end servers are required for catering such kind of dedicated session charging request. So operator have a challenge that they have millions of subscribers to serve, so they have to categorize the subscribers, so that means they can categorize the subscribers, they can either categorize the service itself. Okay, so there will be some premium services, there will be some basic services, some mandatory services, and accordingly the operator can prioritize the traffic. Okay, so QoS is a concept wherein there is some class which we have defined for each and every type of service. So if you can see here, the QoS class identifier means, which we call it as QCI. QCI index value starts from 1 to 9. Okay, where each and every class is having some characteristics and some priority. Okay, and the few of the indicators in the classes guarantees you the actual bit rate, means it's a guaranteed bit rate which I'm giving. It's just like that I have purchased some TV, and I have been promised that until 1 year the services will be free. Moreover, for every complaint, the service engineer will come visit your house within 1 hour. So this is a SLA kind of thing, means I'm guaranteeing you. And if this doesn't happen, then you have full rights to go to the court, or you can go to the give the complaint like that. Okay, so that's a different story. Sorry for the very different kind of example, but I was not having any example to tell you. But okay, let's move on to the topic. So QCI, so what is guaranteed bitrate means in any circumstances I'm giving you the guaranteed bitrate, which is, let's say, 1 Mbps speed. 1 Mbps speed guaranteed bitrate I'm giving you for a particular service. Okay, so this is how, and these QCI has been designed by 3GPP, and this is mandatory to be followed. Okay, so, and there is one more parameter, which is allocation retention policy, ARP. So it is used by gateways and eNodeBs for resource priority, useful for call prioritization in disaster or emergency situations. Okay, so okay, these are actually radio parameters uh, there are some priority levels. We should not go deep into it because this is actually not much of my interest also. So, guys, you can Google it more about what is ARP, okay, and what is all these things. So, but I'll take you to this particular table wherein each and every QCI indicator has been classified. And you can see that QCI 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 QCIs are there. Okay. And in these from QCI 1 to 4, this is guaranteed bitrate. GBR means guaranteed bitrate. Means whatever bitrate we are mentioning here. Let's say this is the bitrate. Okay, so whatever bitrate we are mentioning here will be the guaranteed bitrate, and whatever bitrate mentioned here means from QCI 5 to 9, that will be a non-guaranteed bitrate. So what comes in guaranteed bitrate? The first one is the conversational voice. Okay, so that means we make a call, voice call on the mobile from one mobile to another. So these kinds of voice call always have a highest priority because there are many emergency calls or normal voice calls. So calls are always have a priority because nowadays we are in an era where data is everything. But even then, the voice calls always have a highest priority. Why? Because sometimes you might face that data is not there, or the data traffic is huge and you're not able to connect the calls properly, you're not able to hear the voice properly. So that's the reason 3GPP has designed these QCI parameters and the guaranteed and non-guaranteed bit rates in such a way that the basic service, which is the voice, should always be on the top priority. Okay. Now the second one is the conversational video. So video, of course, has a second priority. Then we have non-conversational video streaming, real-time gaming, IMS signaling. So IMS signal is a non-guaranteed bit rate. Then we have voice, video, interacting gaming, non-conversational. All these things are there. So all this is a priority. Okay, when you start working on these IMS and diameter charging, you'll come to know how the QCI parameters comes in. And moreover, if you see my last lectures where I have opened the TCP dump and I've shown you in the GX request how QoS looks like, what are the parameters which comes under the QoS. So basically all these parameters in all together tells you what should be your speed, what should be the quality of service to be given to you, whether it is a guaranteed bitrate or not guaranteed bitrate. Okay, and all these parameters values comes from the network side, and on the charging system side we might be having such flexibility where based on these parameter values we can give the user the actual the bandwidth and the speed for browsing. Okay. Okay, now the call flow of SCUR I'm going to explain here. So this is the call flow of SCUR. Okay, means a normal data charging. When you open the mobile, how the PDB context is created, then how the session is getting charged. Okay, I hope the screen is visible. Yeah. So now see the users, this is the user equipment, means your mobile phone, a mobile station where you have started the data session. Now the moment you switch on the data, there is a PDB context which comes into picture first. So PDB context request comes to SGSN queries the HSS for the profile check. All those things are actually not much relevant to the charging domain. So just go through it like this is the call flow. Profile is get from the SGSN then will send the create PDB context request towards PCEF, GGSN are all the same term. Now GGSN will create a GX session toward PCRF wherein it will exchange the few of the parameters like QoS or some rules, policy rules to the PCRF, existing rules to the PCRF, static rules, and then based on this, if we have a SY interface towards OCS, then PCRF will query the tariff of OCS via SY interface. Okay, SLR initial request will go to OCS. OCS will scan the tariff. Okay, and based on this, OCS will give you the QS, the speed details, and the basically the policy counters. OCS will share the policy counters. So whatever policies are there on the subscriber is there on the PCRF as well as on the OCS. Now the thing is why this call is required is that the account related information means the balance, the quota, all this information will be stored where OCS. However, all the policy rules are created where PCRF, but PCRF cannot impose the rule by itself. Okay, so for imposing the rules, PCRF first have to get the actual status of the subscriber policy from the OCS. There might be some cases where you guys have worked where there is no SY link. So in that cases, the quota is not provisioned on OCS. There might be case where OCS is there, but quota is not there on OCS. Quota is there on the PCRF itself. Either inside the PCRF as a database, PCRF is hosting something and quota is provisioned there, or there will be some external SPR where PCRF is querying the quota. And in the GX itself, it will impose the policy. Okay, but in this scenario, we have the SY interface, we have GX, GY, and SY. Okay, so I will explain you in that perspective. So don't get confused. And if you have any queries, you can write down in the comments. I will try if I can answer your queries. Okay, let's continue from here where PCRF has sent SY request towards the OCS. This SY request, SY is the interface, the request is SLR, the service spending limit request. So in the spending limit request, whatever policy counters PCR is having, it is sharing back to the OCS. Now OCS also have the policy counters, means the packages. Based on those policy counters, OCS will check all the, not based on that policy counter. So whatever policies are installed on the OCS for that particular subscriber, OCS will give all the policy counter status to the back to the PCRF. Now, out of those policy counters, then PCRF will decide which one is applicable. Okay, which rule should be applicable for that particular status. Now, based on that, PCRF will send a signal GX CCA initial towards PCF, and PCF will will start the session. So PCF will give the confirmation to the user equipment that yes, PDF context is now successfully activated. So the friends, PDP context activation is basically you can say a dedicated channel, which is dedicated bridge, which is created first, then traffic will start run on it. So it is basically a signaling flow where PDP means the packet session is being established. Now the charging didn't happen yet because GY didn't came into picture. It's just like authorization happens. Okay, now user is found authorized. Now session will start. So user will start browsing, and the packet will first land towards the normal flow, and then it will come to the PCF, the GGSN basically. Now GGSN, these parameter will flow. These I already explained in the TCP dump in my previous lecture, but here I have shown some glimpse of it. So in the GY CCR request, the credit control request, the parameter which will be exchanged between PCF and the OCS will be RSU, requested service unit. Rating group. Okay, rating group means what kind of website you are browsing, because GGSN knows that what packets are being browsed by the subscriber, and based on that GGSN knows what is the RG group, and we have defined RG group on the OCS it's also so that whatever RG comes here, those tariff will be will be scanned from on the subscriber level from the subscriber profile. So let's say for here is the RGs for general internet, means any website you are browsing. We have some quota on subscriber, and subscriber is browsing something. Now there will be another parameter which is very important. It comes in the interview also, like what is MCC, MNC. So it's a mobile net country code and mobile network code combination. This will help the network operator to understand where the subscriber is roaming. So it is in home location or roam location. Okay, and every country has a mobile country code, and every network inside that particular country has a mobile network code, and the combination of this will help identify that where the user is. And there are calls. There is a call station ID also, which is the APN again, and APN based routing is also there. So APN is very important in that perspective. Then there is user location information. There is a RAT type, and there is a red type tells you whether this is 3G, 2G, 5G connection, like that. Okay, and these parameters will come flow over GY towards OCS. Now OCS will scan the tariff, and based on that, OCS will give what? OCS will give the reservation. So it's a granted service unit. So against this RSU, requested service unit, we are granting some units to the subscriber, and we are granting a validity time also. Now, friends, what is this validity time? So maybe I didn't cover this. I mean, I didn't explain to you about the validity time. So what happens is, let's say I have given you some reservation and your mobile session is idle, means you're actually not using that much. So what happens is the session is intact, okay? And as I told you, there are very high-end servers on the legacy sites which are supporting this dedicated sessions for each and every subscriber. So this is actually not good for the operator, because unnecessary resources are getting consumed, and user is has lying down, means has put down his phone. He's not using the internet, but internet still open. So let's say if the reservation size is high, let's say 10 MB reservation I'm giving, and user is not using anything, then the session will idly put on hold. So what happens is that there is some validity time also, which is associated with this particular request. So this validity time tells that, okay, until this particular time, let's say 30 seconds, wait for 30 seconds. If the granted service units are not consumed within that 30 seconds, then immediately give the update request, wherein whatever granted service unit were given, out of which whatever you have used as a used service unit will be reported back to the OCS. So here you can see allow browsing happening, and then GYCCR update is coming. So update is telling, okay, this much used service unit has been used, and this much requested service unit again you have to give. Okay, now again same thing will happen. It will keep going until there is some threshold reach for an offer. Okay, wherein FUI condition is there, as I explained in the previous diagram. So FUI indicates that your quota is finished. Now the quota is finished, then the final granted service unit will be given, and FUI will come to you. Now the network element understand that quota has been exhausted. Okay, and the moment quota get exhausted, OCS immediately inform PCRF as well. You can see this is PCRF node. So OCS here is informing back to the PCRF also with the SNR, service notification request, that this is the updated counter and counter statuses, means the policy counter and the policy counter statuses. Okay, and then based on that, PCRF also evaluates which policy to be enforced, and PCRF will send the GXRAR towards GGSN, and GGSN will apply that particular rules, the throttling and whatever, stop internet or pay, or whatever has to be done. The rules has to be enforced, means the speed which has to be enforced, or blocking of internet, or maybe the redirection which has to be happen. It can happen. Okay, so this particular, I think we are done with this particular call flow. And okay, now there is one scenario wherein the account is recharged. Okay, so now this was a situation when quota was finished, and there is no other pack for on the user's profile. So internet is being stopped, or maybe you can say that at the lowest stage. So here the use case is like internet is on low speed. Now user has done some recharge. Okay, now the moment user will recharge, OCS will come to know that recharge happens. Now OCS will trigger a GYR towards the GGSN. This is actually GYR will happen, and wait. Okay, yeah, GYR is initiated toward GGSN to inform GGSN that there is new quota being provisioned on the subscriber, and again session should start with the correct speed. Now GGSN will send a success response, and at the same time, see what happens in a 3GBP PCRF network. When the recharge is done, and there is some offer or quota being provisioned on a subscriber level, it get provisioned on both OCS as well as PCRF. Now, so here you can see the offer is being provisioned, means the quota is being provisioned after recharge on OCS, then on the PCRF. And then what is happening, PCRF is informing this to OCS to get the latest policy counters via SLR, and OCS is then giving them the latest policy counters, and based on that, again, PCRF is sending, PCRF here is sending GXRAR because it has to reinstantiate the GGSN to, keep continuing the user with the higher speed, and then GGSN uh, okay, updating the rules. Okay, and this things keeps continuing in this fashion. Okay, so I think we are done with the call flow. So I hope all of you understand the call flow well now. Let me see what else is there to explain you guys. Just a second. Yeah, so this is the okay, I'll just tell you, this is the website which I'm using for making call flow, sequencediagram.org. This is very helpful website. I'm not doing any promotion. It's an open source website. So I'm being using this in my daily job as well as part of my personal interest also. And making the call flows are very easy with this website. If you want, I can have a very quick session someday about on this sequence diagram org, where I can explain you how to make sequence flow diagrams. Okay. So this is a TCP dump analysis for GXRAR. Okay, you can see how this application. This is the uh, you know header which will tell you whether this is GX or GY. So it is a GY request. You can see the code of GX is 16777238. Now here you can see this is the diameter. GY request is will look like this. Application ID diameter credit control application will look like this. Okay. So these are the references from where I have referred this tutorial, and I think we're done. So I'll try to come with some more lectures. You can also suggest me which topic should I come up with, and I'll have to help. So thank you guys. Thank you so much. Bye.